Okay, guys, today we're going to look at some more problems with logs. So let's start with number 1. So we have 8 raised to the log base 8 of 64. So let's try to figure this out. Log base 8 of 64 equals some number, we could call it x. So then 8 to the x is 64, so x is 2. Okay, well now we want to do 8, that is the exponent, right? Because log base 8 of 64 is 2, so put that as the new exponent. We get 64. So if you'll notice, we're right back to this value in the top. And the reason is we have the same base for the entire expression as we have for the log. We were really doing 8 with what exponent will give us 64. So we got 2. And then we said, okay, now raise 8 to that power. All right, so what we're going to do is we're going to try to recognize this shortcut and times when we can use it. So let's look at 2. When we don't have a base for a log written, it means base 10. So we have log base 10 here. So let's rewrite 100 as 10 with an exponent. So we have 10 squared. Then we could rewrite this again as 10 raised to the log base 10 of 5 squared. Well, we just end up then with 25. Okay, let's look down at 4. So 4 is a little different. We have 7 raised to the log base 8 of 1. Well, we're not going to be able to rewrite 7 as 8 with an exponent. So let's see if we can figure this out the long way. Log base 8 of 1 equals some number. 8 with some exponent equals 1. So that means that x is 0. Since 7 to the 0 is just 1. But in the other questions, we want to try to always just write, when possible, the base of the entire expression as the same thing as the base of the log and the exponent. Let's look at 8. For 8, we have 1/2 to the log base 8 of 27. We want to rewrite 1/2 as 8 with an exponent. So let's do this on the side. 1/2 equals 8 with what exponent? Because we need there to be an 8 down here because there's an 8 in the base of the exponent. Okay, so we can rewrite both sides with the same bases. So this is 2 to the negative 1 and this is 2 to the third. So we have 3x is negative 1, so x is negative 1/3. So 1/2 is really the same as 8 to the negative 1/3. So now we can rewrite this again, and we have 27 raised to the negative 1/3. So the bottom number tells us which root to take. So we take the third root of 27, which is 3. And the negative sign in the exponent tells us to flip it or take the reciprocal. So that's how we end with 1/3. Okay, let's look on the next page at number 9. So for 9, we want to solve this. So we're going to rewrite this as 10 to the x equals 2,000. Now we're going to take the log of both sides to finish solving this and to get the variable out of the exponent. So we have x times log of 10 equals log of 2,000. And now to finish solving for x, to cancel out timesing by log of 10, we're going to divide on both sides. Okay, but what we'll notice is that we just figured out that log base 10 of 2,000 is the same as log of 2,000, we really could have used any base, over log of 10. So this is our general change of base formula. If we have log of base x of y, it's really the same as log of y divided by log x. So we can use that to help us with the next questions and to find different ways to rewrite a logarithm that we have. So for 10, we can rewrite this as log base 9 of 1/3. Now that's equal to some number. So we can say, okay, 9 to the x equals 1/3. If this is tricky for you, you can rewrite both sides with the same base. So you have 3 to the 2x equals 3 to the negative 1. So 2x equals negative 1, so x is negative 1/2. Okay, let's look at 12. So for 12, we could rewrite this as log of 7 over log of 2 times log of 2 over log of 49. Well, the log 2's are going to cancel. And then we get log 7 over log 49. Well, that really is log base 49 of 7. That's equal to some value that we don't know. We can rewrite it. 49 to the x is 7. Well, x is a half because we have to take the square root of 49, which is the same as raising it to the 1/2 power. Okay, let's look down to number 16. So we're not going to use a calculator for anything on this worksheet. For 16, we can actually solve for both sides. So 0.1 is the same as 1/10. And when we don't have a base for log, it's base 10. So this really is saying 10 to the x equals 1/10. Well, the answer is -1. On the other side, we just have 2 multiplied by what we know to be -1. So the left side is bigger. Okay, for 17, we can't figure out what the exact value of either side is, but we can figure out which one is bigger by just using reasoning. So we have log base 1/4 of 30 equals x. So that means 1/4 to the x is 30. Okay, thinking about this, we know that our exponent has to be negative because we have to take the reciprocal of 1/4 to get it to multiply to give us the 30. So now let's look at the other side. We have log base 4 of 30 equals y. So 4 to the y is 30. We know this has to be a positive number. If you think about it, we can do even more than that. 4 squared is 16. 4 to the third is 64. So we know that y is a positive number in between 2 and 3. Okay, so that means that the right-hand side is bigger. So you can do the other questions using the same type of reasoning.